So for doing this, there certainly are ways you could do this just kind of looking at the equations, but as we talked about, if you're feeling totally stuck, making a quick sketch of the graphs can be a big help. So I'm going to go ahead and just do that very quickly for each. Is in terms of making a sketch, this one's sine. So I know that sine starts in the middle and it goes up from there. So I know that that graph would look like that. And then for the second one, that's going to be graphing negative cosine. Well, cosine normally starts at the top, but not in this case, because this is a negative cosine, so it actually starts flipped upside down. That means it starts at the bottom. Didn't draw that very well, so I'll make a better sketch. And so I know that graph will look like that. And then for this last one, x minus 270. Well, the 270, I've been doing these for a while, so I know that that's going to be like 3/4 of the way out. And if it's sine, it starts in the middle from there. So I know that much of the graph. Well, if I know that much of the graph, I can backfill from there to know where it's going. And so just seeing those graphs, I can now start looking at which of these they match up with. I don't even need to make each of those graphs, although you can if you want to. Because like for this first one, it's cosine of x. Well, which one of these graphs over here is cosine? It's got to be cosine starts at the top normally, so that would have to be this one. Because that's the graph where if I look over at the axis, the x-axis, the y-axis rather, it's starting at the top. Okay, negative cosine x minus 270. Well, that one's a little bit trickier. Okay, I think I'm going to make a quick sketch of that one so I can see what's happening there. So I'm about 3/4 of the way out here. Negative cosine would be starting at the bottom, and so I know that much of the graph. Well, if I know that much, I can fill in the rest. Now I can tell which one it goes with, right? That's the same as the graph of sine. Well, process of elimination would tell us what that last one is. If you're not sure, you could always make a sketch to see why that is in fact the same, because 90 is starting over here, about 1/4 of the way in, starts in the middle on the way up. And so we can fill it all in that way. That's why that is the same as negative cosine. So that's how they would all end up matching up. Because, of course, sine and cosine graphs, they are in fact the same graph. It's just a matter of where they're starting and how we might be tweaking it along the way, like with the flips that you see here. So then today we're going to be taking a look at just a little bit more graphing. And in this case, if you want to be copying this down, you can. You'd use the back side of the graphing grids that I passed out yesterday. And you'll see why you'd have to use the back side here in a minute. But what makes this one a little bit different from the stuff we've graphed so far is that it's x minus pi. Now the pi being in there is the first big hint that this equation is not in degrees. This equation has been written in radians. And so we're now going to be graphing our sine graph in radians instead of degrees. But actually that's not too hard to do. It's just seeing a little bit of addition. Because like when we were doing it in degrees, I would set up my axis going from 0 up to 360 degrees. Well, in this case, it's not degrees, obviously, it's radians. Well, what's 360 degrees in radians? It's 2 pi. So that just means that this out here at the end is going to be 2 pi. Well, if I know that's 2 pi, I can actually figure out the rest of the stuff in between here. Because what's half of 2 pi? And so halfway between 0 and 2 pi, yes, is going to be pi. Okay, well, halfway between 0 and that then. Halfway between 0 and pi would be, well, half of pi would be pi over 2.
Yeah. Do it.
And so we get pi over 2 there. Now the one that you might have a slightly tougher time with then would be this one. But that's 3/4 of the way through, right? And so you could think of it as 3/4 of 2 pi. Now that's maybe a little bit more work than you want it to be. Okay. Well, it's halfway between pi and 2 pi. Well, what's halfway between 1 and 2? 1.5, right? So that'd be like 1.5 pi, which we normally don't write as 1.5 pi. We normally write it as 3 pi over 2. And so that's what we would actually do at the start, is fill in our axis labels. And notice though, pi over 2, that's the same as what in degrees? 90. And so we're still going by the exact same intervals on the unit circle. The only difference is what we're measuring them in. We used to be measuring it in degrees. We're now measuring it in radians. That's the only difference. But I can now go ahead and make my graph like normal. Now, when I'm making this graph, I've got a change to the amplitude. I've got a change to the midline. The very first thing I want to do then is I want to draw in those dotted lines, so I can keep track of what is where. So I'm going to draw in the midline first. That's going to be up at 1. Now, on this graphing grid, it's not labeled how far up 1 is. I'm just going to go by 1s on here. So I'm going to put 1 here, 2 here, for instance, and so on. I'm not going to use the whole graphing grid, but it's going to be closer to what you're doing on your paper if you are writing this one down, which you don't have to do. I'm going to give you one to write down on your paper here in a minute. And so I start by drawing in the midline. Dotted line always, do not use a solid line. And then the amplitude of 2, remember that's the distance of how far up and down I go to get to the top and the bottom. So I draw a dotted line that's one above the midline and a dotted line that is one below the midline. And now that I have those dotted lines in, I've dealt with the 2. I've dealt with the +1. So all I'm having to worry about now is the fact that I'm graphing sine of x minus pi. The minus pi, that tells me to move it which way, left or right? Yep, to the right. Minus moves to the right. So that tells me I'm going to be putting my first point over here at a positive pi. Now that first point, because this is sine, goes where? The top, the middle, or the bottom? The middle. And so I put my first point right here at the middle at pi. And having plotted that point, we do need to know where we go next, because it could go either up or down. If it's sine like this, does it go up or down? It starts in the middle and then goes to the top. Now that I know that, I know where I am in the pattern. And notice, instead of putting a point every 90 degrees, I'm still putting it at those same intervals. They're just labeled in radians instead of being labeled in degrees. So at 2 pi, I'm back in the middle. If I follow that same pattern heading off to the left, well, then I would say that I start in the middle, top, middle, so next up must be bottom. And then middle. And so then we draw the curve through those. And you have your graph. So we're doing it in radians today, but really it's the same process, right? So, we'll do another one here. All right, so as you're going and graphing this one, the first thing you do need to do is label your axis. And so, for my x-axis then, I know 2 pi is at the far end. And so pi is in the middle, which means that pi over 2 is halfway between those. Really, the only one that you might need to memorize is that this is a 3 pi over 2 between pi and 2 pi. All right, now that we've done that, I draw in my dotted lines for where my midline, top, and bottom go. My midline, that's always whatever is added or subtracted onto the end, so my midline here is at 1. So I draw a dotted line across at 1. My amplitude is 3 here, so that tells me I'm going to be going up 3 and down 3 from that same midline to get to the top and bottom. Now that we got those drawn in, now it's a matter of just seeing where the starting point is. And for that, the only things I need to consider now is this part of the equation, because I already dealt with the 3 and the 1. So I know it's sine, and it's going to be starting at pi over 2. So I go to the right, pi over 2, and sine starts in the middle. And after it starts in the middle, it goes to the top. And now I know where I am in the pattern of the wave here. So it went middle, then top, then middle, bottom. And the nice thing about drawing those lines in is that I know every single one of those points has to go on one of those lines. So I'm not having to think about that all the time. Makes it easier. So you draw your curve in and you're done.